Hello everyone. This is your TR sir. Again, I am here with a new lesson for you all, and the new lesson that we are going to talk about today is refraction of light. In your last classes, like in class 7, you have learnt about reflection of light, okay? Reflection of light. So, refraction of light is altogether different from reflection, where in reflection you were learning about the bouncing of light from a surface. But here in this case, we are going to learn about the propagation. This is what we are talking about. Propagation of light through optical media, through optical media, and that's what we are going to focus on, with how light is going to behave as it passes through different optical media. I'll let you know what is an optical media as well, but before we could proceed, let's try to figure out what actually refraction is and where do you really see it. It's all around you. The only thing is that we need to have a keen sight. What do we need is a good set of eyes to observe the things around us. So let's talk about some of the day-to-day instances where refraction of light takes place. So the first thing that you're going to learn here is some of the day-to-day activities, day-to-day occurrences. The first one is the bent appearance of a straw, bent appearance of a straw dipped in water, dipped in water. It could be a straw, it could be pencil, anything else. It could be a straw, it could be a pencil, anything that you look for. I personally have observed this while having a soft drink. If I dip my straw into water, it appears a bit bent, though it isn't in actual purpose. It's not the bent one, but as soon as you enter it inside the water, it starts appearing bent. Now, this particular phenomenon can be attributed to refraction of light. Refraction of light. Yes, you heard it right. If you take a coin and keep it at the bottom of a container and try to observe it from a distance, it's quite possible that you won't be able to see the coin. But at the same time, someone pours some water, the coin starts becoming visible to you. Now, this can also be attributed to refraction of light. Likewise, fish in a pond appears appears raised, and this particular phenomenon is also due to refraction of light. And not only this, phenomena like twinkling of stars is straightly related to refraction of light. Now, children, as we now have gone through so many instances for refraction of light, let us now try to understand what this refraction of light is. Refraction of light. Refraction of light. So it's a phenomenon. It's a phenomenon due to which a ray of light traveling from one optical media, from one optical media to the other, deviates from its path, deviates from its path. Now that's really interesting to know. We are going to do some Sherlock Holmes thing. That is, we are going to see where are the nuances, small things present in this definition. So it's a phenomenon. Children, what's a phenomenon? In sciences, we refer phenomenon as any change that takes place around us, due to which a ray of light traveling from one optical media. Now, what is this optical media? It's anything through which light can pass. Anything through which light can pass. So you have water, air, diamond, glass, etc. These are all referred as optical media. What happens there? The ray of light deviates, changes its path, changes its path, it deviates, it changes its path. It doesn't move in the regular path that it has to go for. We know that light always travels in straight line. But rather than taking a straight line, it tends to move in a changed path, and that is what we call as refraction. Now, if you are supposed to go in a straight path, why would you change your path until and unless there any sort of hindrance is not there? Now we're going to learn about the fact that what causes the light to change its path and why this refraction is caused. Let's ponder over it. Now you see, you have a source called A from where a straight road goes to your destination B. That means suppose you want to go from A to B in between which there is a straight road, but there is an alternate road as well that goes through C and reaches B. The road might seem to be distant one, but it's an alternative. So this is road number 1, this is road number 2. So in any given day, you would prefer route number 1 as it happens to be the shortest. But what what if this road has got a lot of traffic someday? Lot of traffic. There is lot of traffic in this road number 1, path number 1. Then which one should be the fastest way? Which one is the fastest way between road number 1 and road number 2? Definitely it's path number 2, though being longer, for which you have to take a certain different path, a deviated path, but still you will reach your destination quicker as compared to path A on that given day. So same thing happens with light, children. Light, while it is traveling from one optical media to the other, has to suffer, has to suffer a change in speed. When I say it has to suffer a change in speed, it could be an increase in speed, it could be a decrease in speed. Now, as in case of the road, there was traffic which was causing decrease in speed of the vehicles, and for which you have to take a different path. In case of light, it is optical density. It is optical density of an optical media. Optical density of an optical media. Now, optical density of an optical media is a physical quantity which tells us that how fast or how slow light is going to travel in a certain media. Let us cut these things short and try to understand in a layman language. Suppose you are standing at point P and you have to go to point Q. In between P and Q, there is nothing but a ground. And say the distance is 100 meter. Okay. Now there is another 2 points, say A and B. And between these 2 points, there is water. There is water. And one has to swim the 100-meter distance. The same 100-meter distance one has to swim. This is water and this is air. Now you use your mind and tell me which one is going to take longer time. And definitely you will come to the conclusion that here it's going to take a longer time. Why? Because the amount of resistance offered by water is far more as compared to air. You can take this analogy of your speed through air and water for light as well. As light travels through air, its speed remains comparatively high as compared to water. Now, what to do with the optical density here? Here, the optical density of air is less as compared to water. It is therefore it is known as less denser, or you may say it to be rarer. Let me just write it this way. Optical density is less. Optical density of air is less than water. So from this we can conclude that light travels faster in air and slower in water. Now from this one can take a fair amount of idea about optical density. Now let us try to figure out one more thing. I told about air and water. Let's take another example to make things more uh, clear so as to create a better understanding of this thing. Now, if we have to consider 2 points, say C and D, with water between them, it's water, and there are two more points, that is F and G, between which there is glass. Now, you just use your common sense and tell me whether water or glass would provide more resistance. And definitely you would come to a conclusion that glass is more denser as compared to water, and that's going to provide more resistance. Particles are more compactly packed. You're true. And the same things applied for light as well. Light gets more resistance from the side of glass as it has to travel through it, and the speed reduces further low. So optical density is more for glass. Optical density is more for glass, and here optical density is less for water. Optical density is less for water. So if I compare the speed of light in water and glass, light travels faster in water. Light travels faster in water as compared to glass. Light travels comparatively slower. Light travels comparatively slower. Now, this thing might have been clarified to you that it's the optical density which causes this change in speed. So, higher goes optical density, lower comes the speed of light. Lower comes the speed of light. Higher goes optical density, lower comes speed of light. Till now, you need to understand these nuances of these phenomenon known as refraction. You have come across the definition of this particular phenomenon. There are different terms related with it, like optical density, the speed of light. Now, let me uh, give you a few questions so that you can practice well. Try to note them down. What is refraction of light? Number two, what causes the refraction of light? Number three, what causes change in the speed of light as it passes through a media? Try to figure out these answers. Till then, let me take you to another concept of refraction, the concept of denser and rarer media. You see, calling an optical media denser or rarer is entirely relative in nature. Relative means you just can't label a particular optical media as denser or rarer. For example, say I have got air and water. Here, the optical density of air is less. Optical density of air is less, and optical density of water is more, based on which we can say that the speed of light in air is more and speed of light in water is less. Hence, we can label air as a rarer media and water as a denser media. Now, you can easily see we are having a pair of media where one of the media has got a lesser optical density. It has been labeled as the rarer media, and the one with a higher optical density has been labeled as the denser media. Now, if you just change these things, okay, just take for consideration, let us see what we can do in this regard. Okay. So children, you see it here. We have taken water and glass. Here comes the magic. Water and glass, if you compare, water has a lesser optical density in comparison to glass. In comparison to glass. So if you see it here, water will be having a greater speed of light as compared to glass. So can you say me which of the two will be a rarer media? Yes, you thought it right. It's the water which is going to be the rarer media and glass which is going to be the denser media. So it becomes completely clear to you that you just can't label a particular optical media as rarer or denser. You need to compare two optical medias and their speed and the speed of light in them, or the optical densities they have, after which only you can label them as whether they are rarer or denser, that too when they are being compared with each other. Hope this session was useful to you people. I'll be back with more informative lecture sessions on this chapter. Till then, good day.